Hello everyone. Today we're going to talk about levels of measurement. The first level of measurement we want to discuss is nominal, which is also called categorical. These are variables that are named. One is not necessarily greater or less than the next. For example, breed of dog, like pug, bulldog, or Bernese mountain dog. Pizza toppings like cheese, pepperoni, sausage, pineapple. Gender, male and female. Colors, red, orange, yellow, blue, green, purple. And cookies like chocolate chip, peanut butter, snickerdoodle. Now, if you notice, these things are just named. A pug is not necessarily better than a Bernese mountain dog. Red is not necessarily better than purple. Chocolate chip cookies are not necessarily better than snickerdoodles. Although, everyone has their favorites. But as far as measuring goes, we cannot say that females are better than males or pepperoni is better than sausage. It doesn't make sense to say things like that. So a nominal variable is a variable that's just named. Now, this might help a little as far as a visual goes to remember this. Numbers assigned to nominal variables in research have no meaning or weight. For example, if you look at these numbers, now I'm not a sports person, I think these are maybe basketball or something like that. Jerseys, I don't know. But the point being here, these numbers assigned to a person, they're not saying that this person is better than this person because this person's number 1 and this person's number 19. These are just arbitrary. They're random numbers and they're assigned to these people, but they don't hold weight or value. And that's the same thing in research. If you gave when you enter your information in SPSS for males and females, you could assign, when you go to run tests, you can assign males to be in group 1 and females to be in group 2, but it doesn't mean that males are one better than females or females are one better than males. Either way, that's meaningless, because you could actually switch them and put females as 1 and males as 2 and it would give you the same type of results. Now, the next step up is an ordinal variable. These indicate order or ranking, but they do not tell us the difference between the rankings. The distance is not meaningful. If you look at this little example up here, hot, hotter, and then hottest. If you can tell, there's a huge jump between hotter and hottest. This is kind of the idea. There's not intervals between these that are equal. So for example, if you have ranking in the contest for first, second, and third, doesn't mean that first place is twice as good as second or 3 times as good as third, because you could actually have first place scored perfect 100. Second place might have scored a 90, which was only 10 away. Third place might have scored 60, which is actually 40 less than first place, and they would still be ranked in that order. Low, medium, and high is another example. These, like this, have no numeric value. Another example would be the usual Likert scale that you see that says dissatisfied, slightly dissatisfied, neither satisfied nor dissatisfied. Slightly dissatisfied and satisfied. These are technically ordinal. This is technically an ordinal measurement. And level of education is also another example here. Elementary school, some high school, and so on, all the way to PhD. There's no real interval of differences between these listings here. And like I said, same way with the Likert scale, you really don't know what the distance is between these things. Now here's a visual. If something's rated very low, low, medium, high, and very high, this is talking about risk value of something. You can tell that there's not an equal interval between these things. So that's ordinal is order in ranking, but there's no necessary equidistant value between each one of the rankings. Now here's another visual. Order in all things. These variables have order and rank, but the distance is not equal. And this is kind of a good visual of it. First place you can see is higher than second and third, but second and third look about the same level. Second might be a little higher than third here, but you can tell that there's a big difference between first and second. Now, interval is another level of measurement. Interval has order, but the distance between the scores is equivalent and meaningful. 0 is also meaningful. For example, Fahrenheit and Celsius are measured on an interval scale. 100 degrees is twice as hot as 50 degrees. Now, interval, we're also going to say level of satisfaction. I realize that we just had that on ordinal, but in research, people typically use the Likert scale as an interval measuring scale. They will give weight to these names. The dissatisfied might get 1, whereas satisfied might get 5. So they're making an assumption that these things are one away from one another in order to use the statistics that you would normally use on an interval scale. So for research purposes, this is used all the time. However, technically, it is an ordinal variable. But it's close enough. Now, ratings on a numeric scale rate something from 0 to 10, 0 being the worst you've ever seen and 10 being the best. That would be interval. You would expect people to be rating it one away from the next. But 0 would also be meaningful. That means when somebody rates something 0, you know it means something. It's if they rate it that, it's not the absence of something. It's actually saying the worst is 0. So, pulling apart interval, you can see that interval means in between are equal values. Now keep in mind there's no true 0. In interval, 0 has meaning. 0 degrees is a real temperature, a really cold temperature. Finally, we have the ratio scale. Ratio has order, equal intervals, and finally a true 0. Here's some examples. Length and height. Now 2 inches would be twice as long as 1 inch, and 0 inches is the absence of length or height. It means no length or height. Weight is another example. 2 pounds is twice as heavy as 1 pound, and 0 pounds is no weight. It's the absence of weight. Finally, time. 2 seconds is twice as long as 1 second, and 0 seconds is no time. So these things make sense to be on the ratio scale because they are equidistant. They have intervals that are equidistant, but they also have a true 0. Now the ratio scale, it's a little different because of the way the letters fall. But I've pulled these apart and color coded them, and I have that the ratio requires interval and true 0 because you have intervals, but you also will have a true 0 point. Right? 0 meaning that a 0 does stand for 0 something. It's not meaningful to have like 0 pounds doesn't really mean any pounds. Now here's some characteristics. I found a table characteristics on Google Images, but it wouldn't work on my slide. However, I converted it into something that would work. Here we see that all of these have some classification, and ordinal, interval, ratio have order. Interval and ratio have equal intervals, and ratio is the only one with a true 0 point. So having a table like this is a good idea to keep handy if you ever have questions about what types of measurement you're doing. Now, here are some ways to use these types of data, and I really feel this is something important that people should have handy also. You can use mode, counts, and frequency for all these types of scales. Median, minimum, maximum, and range you cannot use for nominal, but you can for the rest. And mean, variance, and standard deviation are only meaningful for interval and ratio scales. Basically, these different types of data are used differently in science. The statistics that we can use on them are different. So in summary, nominal data are just categorical. Ordinal indicates order, but no meaningful interval. Interval, these have order, but also equal distance between one another. Ratio has order, equal distance between intervals, and a true 0 point. And these data are basically used in different ways in statistics, and that's why they're important to learn.